A large tipping floor for incoming material is arranged so that multiple trucks unload their contents simultaneously. The tipper empties the contents of the dump trailers onto the tipping floor. The materials brought to the tipping floor are loaded into 2 drum feeders that equalize the flow of material entering the system. Sorters remove rejects such as large metal parts, electronic devices, and any objects that could damage the equipment. They also remove plastic film by using a vacuum system equipped with hoods that are placed above the sorting stations. Once the rejects are manually removed, the stream of material is sent to a Mac OCC screen to collect the cardboard. The cardboard bounces off the moving parts while the fibers and containers fall between the discs. The cardboard then undergoes quality control. The fiber is now sorted into 2 lines. The material that falls in between the discs of the Mac OCC screen undergoes a second manual pre-sorting before entering the scalping screen. The scalping screen is equipped with steel discs to break the glass early in the process to protect the equipment and prevent contamination of material. Fragments of 5 inches and under fall onto a fine screen that is located underneath. This separator redirects the 2-inch and under pieces to the glass cleaning system. On both lines of fiber, there are 2 Mac News screens, one on each side. They separate the paper from the containers. Newspaper travels up the slope of the separator while the containers fall in between the discs or off the end of the separator. The materials that fall between the discs of the previous 4 separators are directed to a 5th Mac News screen for newspaper to increase the rate of recovered fibers. The fibers exiting the 5th Mac News screen are sent to an optical sorting unit where contaminants such as brown cardboard, metals, containers, and plastic film will be removed. The stream of paper coming from the fiber line is finally directed towards a manual quality control before being sent to a dedicated bunker. Two Mac 3D finishing screens each receive distinct material streams. Assigning a different task to each finishing screen is a distinct advantage. Fragments from 2 to 5 inches that come from the scalping screen are sent to the first separator. The materials that fall in between the Mac News screens are led to a second separator. In the Mac 3D finishing screen, the materials are sorted into 3 streams. Particles of 2 inches and under fall in between the discs early in the process and are sent to the glass cleaning system. Containers roll onto the side, and mixed paper sticks to the rubber disc to go back up the slope of the separator. The Mac Ballistic separator is not included in this system, but is an interesting alternative to the Mac 3D finishing screen. It separates flat bodies from hollow bodies in addition to removing fines. The stream of mixed paper that travels up the Mac 3D finishing screen's slope will be cleaned by 2 optical sorters. The optical sorters eject the plastic and the remaining metal, which then head into a flat and light separator to be cleaned of all impurities and contaminants before heading to the container line. The mixed paper is finally sent to fiber quality control. The containers are now sorted. Manual sorting is first performed to remove 3-dimensional papers such as telephone directories and carton boxes. The stream of containers then passes under a ferrous magnet to remove any steel cans. Once ferrous metals are removed, the other containers are sent to an optical sorter which ejects HDPE plastics. These go through a final quality control before being redirected towards a dedicated bunker. Other containers are crushed between 2 roller compressors into a plastic perforator to facilitate the plastic optical sorting and eddy current sorting for aluminum cans. This also increases the capacity and quality of the bales. An eddy current magnet ejects aluminum cans. They undergo a manual quality control before being directed into a dedicated bunker. The stream of containers is directed to an optical sorter which ejects PET plastics. A conveyor divided into 2 halves serves as the 2 exits of the optical sorter. One half moves the ejected PET while the other moves the stream of remaining mixed plastics, aseptics, and Tetra Pak type containers. The last optical sorting unit of the system is divided into 2 parts and receives the previous optical sorter's ejections. On one side, the stream of PET will be cleaned of any contaminants and will then be sent to the mixed plastics. On the second side, the remaining container stream will be sorted into 3 categories: aseptic and Tetra Pak type containers, mixed plastics, and rejects. Manual quality control is done on the ejected materials at the very end. The materials sorted during the process were sent to the moving floor bunker, Mac Motion Floor, which facilitates transportation to the balers. Two horizontal balers are used for baling containers and fibers. Designed by Machinex, these single ram extrusion balers, which are high in density, are among the most innovative in the industry and incorporate the steps of pre-pressing and shear. An operator manages the work done by the baler with a control system developed by Machinex. Some manual sorting stations in the system are equipped with hoods that create a vacuum for the plastic bags. These hoods are connected to a central system that leads the bags to a dedicated closed-door baler. A glass cleaning system receives the fines from the fine separator and the Mac 3D finishing screen. This system is designed to remove all fragments from the glass, which helps to obtain a very high-quality final product. Initially, an air separator pneumatically removes the light particles such as shredded paper. Oversized particles emerging from the trommel are diverted with the fragments of paper to rejects after they first pass through an eddy current magnet to remove all the remaining aluminum. The glass fragments pass through the sieves opening and are sent to a silo outside the building by a bucket elevator. The glass from the glass cleanup system is sent to a high-set silo that will directly fill up the trailer trucks which will carry the glass to the recycling facility. Cardboard from the commercial sector is discharged into the commercial tipping floor and will be sent directly to a baler. Rejects from the system are sent into two compactors located outside the building. The operations room, located in the center of the system, provides a complete overview of total operation. It includes a SCADA system developed by Machinex. The SCADA is an excellent management tool for the material recovery facility operator to obtain all the necessary reports in order to detect losses in production and improve profitability.